Welcome. Today I'm going to talk to you guys a little bit about physics and hopefully smooth over any fears that you might have about what's in the class. You may have taken biology and chemistry, and a lot of the skills that you developed in bio and chem are going to be useful in physics, probably because they came from physics originally, and we'll talk about that in just a minute actually. Now I'm not going to lie to you. People have a kind of a conception of physics that I think is sort of a bad one sometimes. They say things like, "Ooh, physics. Oh, that's a hard class. Why would you want to take that class?" Or, "Ooh, physics. I'm not a math person, so I don't want to take physics." Physics class that you take in high school can be a very difficult, very math-heavy class. But I have tried my best to set it up, in this case, so that it has a pretty good balance between the hands-on, the things that you're going to actually do, the concepts that you actually feel with your hands, and the math that you have to do to be able to explore it. So I hope that I've come up with a pretty good mix or pretty good balance of things. That's my goal, at least. Now, this is the first of our video notes. So you're going to want to take notes on this. Obviously, the notes for the first one are just going to be pretty simple, pretty basic, just to get you prepared. I am going to ask you to ask a question at the end, like you will have to do at the end of every video. And then we'll talk about some of the main themes that come up in lots of the questions that you guys have submitted the next day. So go ahead and take a look at the note sheet if you haven't already, and maybe look at the Google form in which you have input your question, and come on back when you're ready, and then we'll go ahead and talk about what you're going to study this year in physics. Okay, if you've gone and come back, fantastic, welcome back. If you're still here, let's go ahead and get to it. So I'm going to slide myself off to the side here so you guys can have a chance to see what we're talking about. So here we are, video 001, Themes in Physics. Now we're going to start with this concept of physics being the most basic of all of the sciences. Now, this is a little strange, so I'm going to go ahead and draw this out for you here as a diagram so you can see what I'm talking about here. You guys probably took, as a freshman, probably took bio, and then you took chemistry, and now you're taking physics. If you didn't do that, that's totally okay, no problem. I'm not going to quiz you on anything that you learned in any of those other classes. So no worries, it's not a big deal. It's kind of interesting, though, why we have them in that order. And the old physics teacher, or I should say science teacher, rule was that back in the early 1900s, when they were putting together the generic sequence for classes that people would take in high school, counselors just didn't know anything about these classes, so they just put them in alphabetical order. So you could see B, and then C, and then P, alphabetical order, because there's really no good reason for putting them in this order. In fact, let's look at it for a second here. In physics, we study all sorts of different topics. In fact, it's kind of the most general of all of the sciences. And then what we do is when we learn those skills and strategies and techniques and concepts, we then apply them in specific instances, like, for example, in chemistry. And so chemistry is really sort of a subset of physics. A lot of the same concepts and techniques and rules that you learn in physics, or that were developed in physics, have become the basis for the study of chemistry. So once you've learned chemistry, then you can apply a lot of those techniques and strategies and skills and concepts, of course, to biology. And so it would make the most sense if you went in the opposite order, because physics is the most basic of the sciences and has the most general techniques, and then chemistry is a little more specific, and then bio is a little more specific even still. So it would make more sense to go ahead and go in the opposite direction. And in fact, some high schools do it that way. We do not. We go the traditional route, and that's okay. It allows us to do a little bit more interesting math in physics, which is good. It does kind of hurt you, though, when you take bio, because you have to know a little bit of chemistry, like for example when you're talking about proteins, to be able to discuss that. Proteins are really something that would be better studied after chemistry, because chemistry is really talking about how those long chains of amino acids work together and how they fit in certain ways. And that chemistry idea, how those chemicals work together, really has to do with electrostatic interactions, which are studied in physics. So ideally, you'd go the opposite direction, but that's okay. Physics also is the basis for other sciences, like, for example, astronomy, which is sort of my passion, if you will. So astronomy and physics are the two oldest of the sciences, if you will. They kind of, astro is probably the oldest, and then physics kind of grew out of that. Physics and chemistry together, and maybe a little bit of bio, can come together to form the geology or geological sciences. So we've got that as well. But you see, down here at the bottom, physics is sort of the basics. There's no arrow that points inward towards physics. That's not to say that studying chemistry didn't help physicists out, or studying astro didn't help physicists out, or geo. That's not true. But all of the concepts, all of the ideas and strategies and techniques were developed in physics first. So we call it the most basic science, because it is sort of the foundation of all the other sciences. So hopefully that makes sense. And hopefully I didn't make anyone mad who is a big fan of chemistry or biology. If I did, come and talk to me about it. All right, so I'm going to go on to the next slide here. So all sciences explore the concept of energy. In biology, you talked about how energy is needed to replicate cells, or energy is needed to replicate DNA, or to move, let's say, to keep things alive. All of those concepts in biology were dealing with this concept of energy. In chemistry, you probably talked about how chemical reactions occur when certain types of energy are present, or certain amounts of energy are present. And so you talked about energy in very specific cases. Physics, on the other hand, and again, this is why it's one of the more basics, why it's the most basic science, talks about all the different types of energy, and really tries to encompass all of the exploration of energy. So for us, I'm going to say that energy is our central theme. Now, there's two types for our explorations here. The two types of energy are it's pretty simple to understand. Specifically, the first type of energy is very easy to understand. So type 1 is energy of motion. And so you guys, if you're waking up in the morning and you feel like you just can't get out of bed, and you say, "Mom, I can't get out of bed because I have no energy," really what you're saying is you can't use the energy that you have stored in your body to create motion. Now, of course, that's not true, not really, but it's a good idea to keep in your head, because it is something that's important for physics. One type of energy is motion, and specifically in physical terms, we call it kinetic energy. And there's all sorts of different instances in which you're going to have kinetic energy. So that's the first type. It's energy of motion. And so, again, as I draw this out, my pen gets a little crazy sometimes. There we go. There we go. As I draw this out, I'm going to draw out just a simple diagram for you to see it, to try to keep it in your head. I have a box sitting on a floor, and that box has some motion. And so that's your kinetic energy. The second type is a little bit trickier to understand in terms of sort of the getting up out of bed thing. Let's imagine that you're on a bunk bed for a moment. So if you've ever had a bunk bed, I had a little brother who's just a couple years younger than me, so I had a bunk bed, unfortunately. A bunk bed is a bed in which you have sort of two layers, right? You have two beds that are stacked up. like so. And unfortunately, for usually the younger brother or the smaller brother, you end up having to sleep. There we go. Sitting like that on the floor. So the younger brother usually sleeps on the not so cool lower bed, while the older brother tends to sleep on the upper bed. Now, for me, I was trying to be a nice guy to my little brother, and so I would often let him sleep on the top. However, my little brother likes to roll around in his sleep, and so sometimes he would go ahead and fall right off onto the floor. Because he was so high up, he was able to pick up speed and collide with the floor with a huge thud. Many times he did that and didn't even wake up, which I find very hard to believe. But it is true. It happened many times. So the fact that he was higher up allowed him to pick up speed, and so we would say had allowed him to gain more kinetic energy. So the fact that he was higher up somehow gives him the ability to have stored energy inside of him, which he can then convert into motion. So the first energy is motion, and the second energy is stored, waiting to turn into motion. So stored energy. And that stored energy has another physical term that goes with it, and that's potential, because it has the potential for turning into motion. So potential energy right here. And I'm going to run out of room, so I'll do this. Potential energy. And I already drew my diagram, so I'm not going to worry about that for you. But you can remember my brother falling out of bed if you wish. Anyway, so that's the idea. So we have two types of energy, and they're going to come up again and again in different forms. Motion is pretty well motion, although there's linear and rotational kinetic energy. And then stored can be energy can be stored in lots of different ways. You store energy in a battery. You store energy in an object that's high up. You store energy when you have two magnets and you bring them close together. All of those things are stored energy. So we're going to explore that over the course of the year here. So let's move on to the next slide, which is, I think is the last one here. And that's which topics we're going to cover over the course of the year. I'm going to hide myself there. Hopefully that worked. So let's talk about real quickly what we're going to cover over the course of the year. In the first quarter, we'll talk about the themes in physics, which is what we started to talk about now, linear motion, and then projectile motion. Projectile motion, another way of thinking that is motion in two dimensions rather than linear motion, which is just motion in one dimension. In quarter two, we talk about forces. Now, forces are what cause things to move, so we talk about the causes of motion. Then we expand our understanding of motion to talk about rotational motion. And finally, we finish off the semester by talking about gravity and how gravity works. Gravitation is one way to store energy and then cause stored energy to become kinetic energy. We start the second semester by talking about momentum. Anybody who's watched any NFL football knows a lot about momentum, and so we'll tap into that when we get there. Then we come to work and energy, and so this is when we actually spend our most time specifically talking about energy and the concepts in there, and how different types of energy can be transformed. And then we finish off with a very short unit on relativity, just to give you an idea of how Einstein's work, specifically about energy, relates to all this stuff and motion. We finish off the year with waves and sound, so we get to talk about music and noise and all sorts of great topics there, and then light, and then electricity. Now, for me as an astronomy guy, light is my big topic, so I may spend a little bit extra time on that, but we'll see how that goes. Hopefully that makes sense. All right, I'm going to bring myself back here. And I wanted to thank you guys for watching. I know this is the kind of a different concept for a science class for many of you, so do the best you can with it. Oops, I will hide myself again here. There we go. So I just wanted to remind you to not forget to take a look at the notes sheets. That has to be submitted after you've gone ahead and watched this. Obviously, this one is going to be pretty basic. And then make sure that you submitted a question. In this case, you might want to ask a question about specific things that we're going to cover, or specific things about the class, maybe policies, things like that that I haven't really covered in any other way. So please feel free to do that. Okay, with that, I'm going to bid you guys a farewell. Good luck to you. If you have any questions about any of these ideas or physics in general, please let me know, and I'll go ahead and answer them as best I can. Welcome to the class. I hope it's a good year for you. Thanks.